Hi kids, now we'll be going with this J advanced paper discussion. You can look into the first question. There were two particles whose position vectors were given. So position vectors were given. So if you differentiate it, you will be getting velocity vectors. If you differentiate it, you will be getting acceleration vectors. But they were asking what is the velocity at t equals to 1. So I just substituted t equals to 1, t equals to 1. So I will be getting velocity at t equals to 1, acceleration at t equals to 1, velocity at t equals to 1, acceleration at t equals to 1. But they were asking to observe second particle with respect to first particle. So velocity of second particle with respect to first particle will be v2 minus v1. So when you subtract this, you will be getting this. Acceleration of second particle with respect to first particle will be a2 minus a1. So subtract these two, you will be getting this. So basically they are not in the same direction obviously. So velocity is in some direction, acceleration is in some direction. What is that you will be doing? You will be resolving the acceleration along the velocity and perpendicular to the velocity. This is going to be tangential acceleration. This is going to be centripetal acceleration. Centripetal acceleration equals to v square by r. So radius of curvature will be v square by centripetal acceleration. Centripetal acceleration is a sin theta. So I need to find a sin theta and substitute it back here. V is V's magnitude I know. V's magnitude is root 17. So v square I know. A's magnitude I know. So if I find sin theta, I can substitute it back and I can get the answer. For that I am going with the dot product. Cos theta is a bar dot b bar by mod a into mod b. So a bar dot b bar, when I take the dot product, 2 plus 8, 10 by magnitude of this thing is root 17, magnitude of this thing is root 8. From there I will be getting cos theta. If I know cos theta, then I can get sin theta also. So I will be substituting sin theta back and I will be doing the calculation and I will be getting the answer. Those who are into mathematics probably will be writing v square by a sin theta as v square by a into sin theta is a bar cross v bar by mod a into mod v. You can modify the same thing and you can write it like this. So mathematically you can straightforward get the answer. Right? A particle of mass, okay, you can look into the question. So potential energy is given. They were asking if the total mechanical energy is 0, maximum speed. So potential energy is given, a value, b value over 1 given. So potential energy is this thing, first differentiation is this thing, second differentiation is this thing. I want to see when the potential energy is going, first differentiation is going to become 0. It is going to become 0 at 3 points. One is x equals to 0, the other one is x equals to plus or minus root 5 by 2. Anyway, it is symmetrical along positive and yeah, it is symmetrical along y axis, right? And I'll show you the graph. The graph is going to look like this, that you can plot by yourself. So let me check. Anyway, once you plot the graph, you will understand that x equals to 0 is not minimum potential energy, but yeah, let me do it. Potential energy at x equals to 0. When you substitute x equals to 0, potential energy will turn out to be 0. No. When you sub at x square equals to root 5 by 2, x square equals to root 5 by 2, you can substitute, then you will be getting potential energy is minus 25 by 4. Total mechanical energy is 0, they said, so kinetic energy here is going to be 0, kinetic energy here is going to be 25 by 4, kinetic energy is half mv square, from there you will be getting b. So if you want to understand much better, you can plot the graph and you can see potential energy is going to become 0 at 3 points. So whenever potential energy is going to become 0, kinetic energy is going to become 0, so it can't cross this point anyway. So the next question, a bead is sliding along the helix, so acceleration as a function of time. At any small curvature is looking, any small part is going to look like an incline. So all those things will be having same inclination theta. So I can visualize this is a part of some inclination where the angle is theta, velocity will be this way and acceleration will be g sin theta tangentially. So g sin theta will be increasing this velocity. So velocity speed at any time will be given by g sin theta into t. So tangential acceleration I can get easily. Now centripetal is slightly it's not straightforward because radius of curvature of helix won't be same as radius of curvature of that circular thing. Anyway, I'll show you the next example where you can calculate the relation between radius of curvature of helix and radius of that circular thing. Whatever it is, centripetal acceleration will be proportional to v square. V is g sin theta into t form. So centripetal acceleration is proportional to t square. Tangential acceleration is constant, centripetal acceleration is proportional to t square. So I'll be getting resultant acceleration is of this form. So I just need to plot that, and at any time this acceleration will be there. So at t equals to 0, acceleration is not 0. You can eliminate these two options. So it is one of these two options. So the only thing you should see is slope is decreasing or slope is increasing. So you can see slope will be increasing from this figure. Right. So if you want to understand the relation between radius of the circle and radius of curvature of the helix, this question was from work energy, power and circular motion revision class. It will be there. So anyway, I'll be just scrolling so that you can pause and you can read and understand it. So if radius of circle and pitch were given, then what is the radius of curvature of the helix? Radius of curvature of the helix, this is the radius of curvature of the helix. It won't be same as radius of curvature of the circle. It will be something. velocity of wedge C when B goes down by 1 meter. Now, if B goes down by 1 meter, this will go up by half meter. If this goes up by half meter, this will go down by half meter. This part and this part 1 meter will appear here. So that's the idea. I am putting it in the figure. If this goes up by 1 meter, this will go down by, if this goes up by half meter, this will go down by 1 meter. So at any moment, see, now it can see this motion like, see, wedge is going to move in the horizontal direction. So wedge motion is easily predictable. This motion is going to be complicated. This motion is going to be complicated. But with respect to wedge, this is going to go along this direction. This is going to go along this direction. With respect to wedge, if this goes half meter, this will go 1 meter. So motion of this guy is motion of the wedge, motion of the wedge. Motion of this guy is motion of the wedge, motion with respect to wedge. Motion of this guy is motion of the wedge and motion with respect to wedge. Now similarly, if I want to talk about velocity of the wedge, let me say capital V. So velocity of this guy is velocity of the wedge, velocity with respect to wedge. Velocity of this guy is velocity of the wedge, velocity with respect to wedge. Now if this speed is V, then the speed will be 2V with respect to wedge, because if this goes by distance x, this will go down by 2x, right? So that's the idea. Now all the forces are, there is no external, if I take A, B and C as my system to get this entire thing, there is no net horizontal force. So momentum should be conserved along x-axis. If I do momentum conservation along x-axis, this momentum plus this momentum includes this velocity as well as this velocity. This momentum includes this velocity as well as this velocity. So if I make net momentum equals to 0 along x-axis, I'll be getting this equation. You do it in your own way. What I do is, I know it is linear form. So I'll be taking this x separately. So that is like 5 plus 5 plus 10. 20 into V, momentum in the left direction equals to 5 into V cos 37, 5 into V cos 37 and 10 into 2V cos 53, 10 into 2V cos 53. So left side momentum equals to right side momentum I will be doing. You can do it in your own way and you will end up with this relation. Now what is capital V? Capital V is the velocity of the wedge. What is small v? Small v is the velocity of 5 kg block. So 2 times of small v will be velocity of 10 kg block. Those two, this v and this 2v are with respect to the wedge. Right? So that's one equation, momentum conservation equation. Now how many variables I brought into picture? I have brought 2 variables into picture. So I should write 2 equations. One is momentum conservation equation. The other one is going to be energy conservation. If this goes down by 1 meter, what is the vertical height it will be dropping? So drop in potential energy is going to be this 1 cos 53, 1 sin 53. So mgh, h will be 1 sin 53, mgh. Drop in this potential energy will be, okay, increment in this potential energy will be, this is half cos 37, half sin 37. So mg into h, half sin 37. Drop in potential energy of this guy minus increment in potential energy of this guy. Now this is the energy available for me. This energy will go as kinetic energy of this guy plus this guy plus this guy. Kinetic energy of this guy is half into 5 into v square, which is simple. Now kinetic energy of this guy, resultant velocity is summation of these two. Now I can't go like this because it is not linear relation, it is v square. So I need to find resultant velocity square. So this angle is 37, so this angle is 180 minus 37. So you know the angle between two vectors, so resultant is going to be root of a square plus b square plus 2ab cos theta, and you are taking velocity square, so root is not coming into picture. Now similarly, this guy's kinetic energy will be half into that guy's mass into this guy's kinetic energy will be half into that guy's mass into that guy's velocity square. Again, that guy's resultant velocity will be resultant of these two. This angle is 53, so this angle will be 180 minus 53. So capital V and 2V, right? So those are the 2 equations you should be writing. One is momentum conservation equation, one is energy conservation equation. Now there are 2 variables, 2 unknowns, so you can solve them. So we need to find capital V. So instead of small v, I will be putting 5 by 4 times of capital V. Instead of small v, I will be putting 5 by 4 times of capital V. Then it's only about solving. I will be just scrolling. In case if you get it wrong, you can just copy it, right? So it's only about calculation. Finally, you will be reaching the answer. 2 things are momentum conservation equation and energy conservation. So pure rolling, you need to find what is the radius of curvature of this point relative to the ground. So we have only one thing to find radius of curvature, that is centripetal acceleration equals to v square by r. You can look at the motion like motion of center of mass and motion about center of mass. So if I want to find the velocity, motion of center of mass, velocity of center of mass, motion about center of mass, it is rotating with omega. So about center of mass, it will be having a velocity r omega, but at the it is pure rolling, so bottommost point velocity must be 0, that equals to v equals to r omega. So resultant velocity will be in this direction. So I need to find the acceleration, and I should resolve the acceleration along perpendicular to velocity, so that I will be getting centripetal acceleration. So resultant velocity here is root 2 r omega or root 2 v. So velocity we found. Now acceleration, again acceleration of this point will be, I can give it as two parts. One is acceleration of center of mass, one is acceleration about center of mass. Acceleration of center of mass, about center of mass, it is rotating with angular acceleration, so there will be tangential acceleration r alpha. I know a equals to r alpha because bottommost point is no slipping, right? Now apart from this one, particles performing circular motion, if the particles performing circular motion, there will be centripetal acceleration omega square r. So this point, I can view it like it has three components of acceleration. One is acceleration of center of mass, the other one is acceleration about center of mass, which again consists of two parts. Now I should find the resultant of these along this direction, because velocity direction was this way, we need to find acceleration perpendicular to velocity. Now this component and this component are going to get cancelled because those are a cos 45, a cos 45 will get cancelled. So acceleration perpendicular to velocity will be omega square r cos 45, that is omega square r by root 2. So I got resultant velocity, I got centripetal acceleration, so I can use centripetal acceleration equals to v square by r. V square I know, centripetal acceleration I know, v square centripetal acceleration, I will be getting radius of curvature, right? Now obviously radius of curvature depends on the frame of reference, that's the reason they were asking radius of curvature from ground frame. The next question, satellite. Okay, so they were saying two satellites have the same mechanical energy. Two satellites have the same mechanical energy, so if they are touching here, their potential energies anyway are same, so their kinetic energies also must be same. So finding kinetic energy of ellipse is slightly hard. For satellite performing circular motion is much easy, we already know. So satellite performing circular motion of radius r, its orbital velocity will be root of gm by r, that is from here to here it is a root of gm by a. So if the speed of satellite performing circular motion is root gm by a, then speed of satellite performing elliptical motion also will be root gm by a. Potential energy, total energy is same. Here potential energy is same, so kinetic energy must be same, so their speeds must be same. I didn't do much, I just marked it. This question, I don't have to explain it, it came in your last exam in your JEE mains, which turn, this is the question. So volume submerged won't be changing. If you want to understand it better, initially weight will be balanced by buoyancy. Weight is mg, buoyancy is density of the liquid into volume submerged into g. Now when it is accelerating upwards or downwards or whatever is the condition, you draw the free body diagram, you write F equals to ma, the equations will turn out to be m into g effective equals to rho into the same v, or like let me call it as v dash. So when it is accelerating, you will be getting m into g effective equals to rho into v dash into g effective form. So basically when you take the ratio of this yellow color thing and that red color thing, you will be getting the same answer. That you must have understood from here anyway, so I am not going to explain it more there. So the idea is, draw the free body diagram, write F equals to ma. Don't forget that buoyancy is going to change according to acceleration due to gravity. When the lift is accelerating upwards, buoyancy is going to become density of the liquid into volume submerged into g plus a. Again, you could have guessed the answer. At t equals to 0, temperature is T naught. At t tends to infinity, temperature is 2 T naught. From there we will be getting only option is A. Anyway, so the idea is, there is gas and see, right now initial temperature is T naught, outside temperature is 2 T naught. Now heat will start flowing, my temperature will keep changing. So when my temperature keep changing, I can't go with any like rough formula. I have to take a generalized moment and I have to do something with the integration. So at any moment when my temperature is T, how much heat I will be taking, how much is the rate of flow, that is temperature difference by resistance form, rho L by A form, which is d by Ka. So this is the rate at which heat will be flowing into me. So if heat is flowing into me, where my temperature is T, if heat is flowing into me, what will happen? My internal energy will increase. So it's at constant volume. So if dq will rise to ncv dt, so the rate, so dt will be coming into picture. Now number of moles were given, it is diatomic gas, oxygen CV is 5 by 2 or degrees of freedom are 5. So from here you can manipulate it, and I just wrote this as lambda because this is our familiar form. When it is of this form, I didn't integrate it. I know like this result, we'll be seeing this kind of thing many times. So general solution will be of this form. At T equals to 0, temperature is T naught. So A plus B into e power minus 0. E power 0 is 1. At T tends to infinity, my temperature will be same as room temperature, 2 T naught. A plus B into e power minus infinity. E power minus infinity is 0. So from here I will be getting A equals to 2 T naught, B equals to T minus T naught. When I substitute it back, 2 T naught minus T naught, I will be getting the required result, where lambda is this thing, right? Spherical body has a radius r. Okay, so they were saying assume surrounding to be of absolute temperature. So basically it is not receiving any energy from the surroundings. So heat evolution rate through unit volume remains same. So there are some kind of sources inside it which is generating heat at constant rate through unit volume. So for unit volume, heat generation is constant. Let me say that is H. So for unit volume, let me say heat generation is H, which is constant. So if the volume is 4 by 3 pi r cube, how much heat will be generated by the body? Heat generated per unit volume into this thing. Now it is the intake by me. So but my temperature is constantly T. So whatever I am intaking, I must be emitting. So this is the rate at which energy is getting generated. This is the rate at which I am emitting the energy. Only when those two are equal, my temperature will be constant. So from here, area is 4 pi r square, 1 r square will go. So you will be getting T power 4 is proportional to R. So that's the relation between temperature and radius. Once you get the T2 by T1 whole power 4 equals to R2 by R1, this ratio was given, you can get the answer directly. Two linear SHMs, amplitude A, frequency, okay. So two linear SHMs, both are of same amplitude, one frequency is omega, one frequency is 2 omega, they are having some phase difference. You should find that given this relation. So let me say x equals to a sin omega t, which is of angular frequency omega. The other one is a sin 2 omega t plus phi, because they said there is a phase difference. Now this should be satisfying this equation, so I will be just plugging in the values. This was the given equation. So I will substitute what is x, I will substitute what is y, and I should be getting the answer. But I know like this equation should be valid independent of time. So why to bother? Let me take t is 0. For any time it should be valid. So let me take t equals to 0. When I take t equals to 0, I will be getting sin phi equals to 1, phi equals to phi by 2. Next question goes like, time varying forces act on the bodies as shown in the figure. You need to choose the correct options. So my idea is like, there is friction here. This side force is 40, this side force is T. So this side force is more. 20 kg, if it has to move this way, see the maximum friction here is 100, the maximum friction here is 150, that you can manage. So if it has to move this way, then this force should be greater than 100, because see, obviously the friction will try to opposite. So the maximum friction in this direction is 100, and this force is more obviously, right? So it can't go that way. So if 20 kg has to move this way, then this force has to be more than 100. So when will that be more than 100? When the time is more than 100. More than 100. If it has to move that way. So if it has to move this way, so basically I am seeing like, is there any chance like they can move together? At what time they will be moving together? Net force. Now if I take these two together, this force is going to become internal force. Net applied force is 3T, but this is 150. So if 3T is more than 150, then it will move in this direction. Both will move together in this direction. When 3T is more than 150, both will move together in this direction. That is when T is greater than 50. So what I understood, this is going to happen quickly than this. So both will be, initially when I start applying force, till 50 seconds they won't be moving. After 50 seconds they will be moving together. So that's the idea. So initially I was trying to understand whether this will be moving towards right or this will be moving towards left, and I concluded this will be moving, when it starts moving, it will start moving towards left. That is, that friction force is going to pull in this direction. It need not be maximum. That friction force is going to pull in this direction, which is more than the applied force. So that's the thing. Initially when I start increasing when I started my time, it was not moving. When T is 50 seconds, these two are moving together in this direction. So that's the idea. So from there, again, nothing you can conclude, or nothing you can conclude. Fine. Thereafter, relative motion between A and B will start. So why is the relative motion not starting? Because both accelerations are same. When will relative motion start? When there is, when the friction is not sufficient to drag this guy. See, this guy, anyway they are moving in this direction. This force will keep on increasing. So this acceleration will keep on increasing. This is in my hands. But this guy can't catch up in this direction because this guy has a finite amount of force. Maximum is 100. So this side force can't exceed more than 100, but this side force is keeping on increasing. So this guy will stop catching up this guy. So when this guy's acceleration is more than this guy's acceleration possible, then there will be relative motion. So we'll be seeing critical condition when these two accelerations will be exactly equal and the friction on this guy is maximum. So what is this guy's acceleration? If I draw free body diagram of this guy, there will be 40 and there will be 100 and there will be 150. I didn't write that. Anyway, they are moving together. So I have taken this entire thing as my system. So 40 minus t, 3t, 3t minus 150. I have taken the entire system and I found the acceleration, that is 3t minus 150 by 30. Net force is 3t minus 150 by mass is 30. I have taken the entire system together and I have written the acceleration. Now that acceleration must be this guy's acceleration also, and friction will be maximum on that guy. So 100 minus t by mass. Net force on this guy is 100 minus t by mass. So this is the critical time. After this, there is going to be relative motion. From here, when you solve it, you will be getting time is 66.67. That is option A is correct. If option A is correct, option B will be wrong. So relative motion is going to start at this time. Again, if I want to summarize it, from t equals to 0 to 50, they are not moving. After t equals to 50, these two will start moving together. When t equals to 66.67, till then they will be moving together. After that, there will be relative motion. Now, option A and option B done. Now option C and option D, the time is more than 66.67. So there is relative motion. There is relative motion. If there is relative motion, friction between these two is maximum anyway. There is slipping between this guy and ground, so friction is maximum anyway. Now at t equals to 80. T equals to 80. T equals to 80, this force. Now if I draw free body diagram of this guy, at t equals to 80, this force is going to be 320. 320, so there will be friction force opposing here 100 and 150. So 320 is pulling force and 250 is opposing force. So 320 minus 250 is the net force by mass is 10. So acceleration of, this is not A, this is B. Acceleration of B is going to be 7 in this direction. Acceleration of B is going to be 7 in this direction. Acceleration of A. On A, how much will be the force this side? This side it is 100, this side it is 80. So 100 minus 80. 100 minus 80 is 20, 20 by mass is 20. So this guy's acceleration is only 1. You can see, still this guy is trying to go that way because he is trying to catch up. He is trying to catch up, but the available force is only 100, but this side pulling force is 80. So this guy is still going in this direction. This guy is going in this direction with 7. This guy is going in this direction with 1. So relative acceleration 6, right? So option D is correct. Then they are asking at t equals to 100 seconds, what is the acceleration of center of mass? So if I want to talk about center of mass, I can take this as my system. So net force is, this is going to be internal force. So this force is 3t and this force is 150. If I take this as my system, 3t and 150. So what is the net force? 3t minus 150. 3t is 300 minus 150. So net force is 150, that equals to net mass into acceleration of center of mass. From there you will be getting acceleration of center of mass is 5. Okay, in this question, there are 2 rings. These are like welded things, but this bead can move along the thing. Now, this bead is not going to act like a rigid body for us because it is changing its position. But you can see along the normal, their motion must be same. So that's the reason I am going to draw the free body diagram. Now, there is bead written here, you just forget it. So this ring and this ring, I am taking it as one figure, and bead I am taking it as other figure. I am drawing the free body diagram of these 2 rings together and this bead separately. Now there will be hinge reaction here, there will be weight of this ring, there will be weight of this ring. Now assume bead is not there. If bead is not there, what will happen? There will be torque. There won't be torque because of hinge reaction, there won't be torque because of this weight, there will be torque because of only this weight. Because of this, it will be rotating. When this is rotating, this particular point will have some acceleration this way. Its horizontal component is going to become r alpha, its vertical component is going to become 3r alpha. That you can manage. those who want to understand it simply, if this distance is r, this will be r alpha. If this distance is 3r, this is going to be 3r alpha. You can do it by yourself. Now, bead which was attached here should definitely have this r alpha acceleration, because well, acceleration along the normal will be same. The other way of saying it is, on the bead there will be normal force in this direction. So by the bead there will be normal force in this direction on the ring. So these yellow things are the forces, and this brown ones also. I didn't bother about the brown ones because I'll be taking torque about this point. So torque due to hinge reaction will become 0, torque due to this weight will become 0. Torque due to this weight is going to become perpendicular distance is 2r into mg. Torque due to this normal is going to become perpendicular distance into n, but both are in the opposite direction, so net torque equals to I alpha. I need to find moment of inertia about this axis. Moment of inertia of this ring about this axis is mr square plus mr square 2 mr square. Moment of inertia of this ring about this axis is mr square plus m into this distance square. This is r, this is 2r, so this is root 5r, so m into 5r square. Mr square plus parallel axis theorem. So moment of inertia of this ring is this much, moment of inertia of this ring about this axis is this much. Total is 8 mr square. So when I write torque equals to I alpha about this point, I will be getting this much. But how many unknowns are there? Alpha and n. So I need to write one more equation. That equation is bead's acceleration is r alpha in this direction. So normal equals to m into a. A is r alpha. So from there I can solve for alpha. I'll be just substituting n value and I'll be getting alpha value. From there you will get option A is wrong and option B is correct. Now they are asking what is the acceleration of the bead. Acceleration of the bead in this direction is r alpha. Now in this direction the only force is mg, so in this direction right now the acceleration is going to be g. So resultant acceleration of the bead is root of, resultant of this acceleration plus this acceleration is r alpha, this acceleration is g. So resultant acceleration of the bead is root of g square plus r alpha we found. So just substitute, get the answer. PV graph is given. You need to find the remaining things anyway. So if I assume this temperature is T0, at constant volume pressure is becoming double, so temperature will become double. From here to here volume is becoming 3 times at constant pressure, so temperature will become 3 times, so 236. From here to here volume is becoming 3 times, so this temperature will become 3 T0. Anyway, that much you can manage. I think B to C it is not constant temperature. B to C it is not constant temperature. There is no constant temperature. Temperature is increasing. Temperature is changing. So there is no process where temperature is constant. So this is going to be wrong. Now A to B. See, if you want, you can start it from the scratch. You can plot it from the scratch by yourself. I am just looking at the options and seeing which is correct. A to B constant volume. A to B constant volume. See, in pressure temperature graph, when volume is constant, V is proportional to temperature and that should be passing through the origin. So A to B is constant volume and C to D is also constant volume. A to B, C to D. Yes, that's fine. So A to B constant volume, pressure is increasing, so temperature will be increasing and its linear relation is increasing. From B to C, pressure is constant, volume is increasing, so temperature will be increasing. From C to D, volume is constant, and pressure is decreasing, so temperature will be decreasing. Pressure decreasing, temperature decreasing. Thereafter D to A, pressure is constant. So that's correct. Now similarly, constant volume. AB and CD are constant volume. From B to C, volume is increasing. So temperature will be increasing. And that should be passing through the origin because it is constant pressure. So you can plot that also. The other one is density. Density is mass by volume. So density and volume are density into volume is constant. From here to here you can't do anything. From here to here volume is increasing, density will be decreasing. From B to C it will be going like this. Then volume is constant, so density will be constant, you can't do anything. From D to A, volume is reducing, so density will be increasing. So that's also correct. Next question goes like, there is a vehicle, okay, probably like this partition thing, I have made it as white color here. Don't bother about what is there in red box, I will talk about it later. So sound wave is getting generated here. So source, I'll be always going with this analogy of like source throwing the balls. That is like this is compression of the sound wave. So source is moving 3v/10 and it is generating sound. So I'm visualizing it like throwing balls. So this guy will be moving at the speed v. Now after some time t, after regular intervals of time r, it is generating sound at some frequency, right? So time period is 1/f. So after 1/f, he will be generating one more compression. This is my idea. By that time, this compression would have traveled some distance, that is v/f, v into t. So this compression has traveled v into t. By that time, this guy will be traveling 3v/10 into t. So what is the distance between them right now? 7v/10 into t. T is 1/f. So this is the distance between them right now. Now he is going to generate one more compression. So basically, the distance between two consecutive compressions or the wavelength right now is going to be 7v/10f. 7v/10f. Anyway, so now a similar thing is going to happen. So the distance between two consecutive compressions are going to be 7v/10f, 7v/10f. So it is going to go like that. And yeah, so when it is crossing, now once this compression crosses this, its speed is going to become 7v. So this ball's velocity is going to be 7v. Now by the time he comes here, by the time he travels this much distance, this guy is going to travel more distance. By the time this guy travels 7v/10f, this guy is going to travel 7 times of that distance because his speed is 7, right? So by the time he comes, by the time he crosses this, after he crosses this, his speed is also going to become 7v, but by the time he crosses this much distance, this guy is going to travel 7 times of that distance. Now what will happen to the distance between these two? Distance between these two will remain same because their speeds are same. So distance between those two balls in this medium was 7v/10f, distance between those two balls in this medium is 49/10f. So wavelength received by the people here is going to be 49v/10f. Now that doesn't matter whether it is A or B, for both of them the distance between these two balls will be same, 49/10f. So option A is correct, option B is wrong. A and B will be receiving it as same wavelength. Now if I talk about A, now the distance between those two balls is 49v/10f. Now this guy is moving with speed v/6. So once he collects this ball, then what is the relative velocity? Relative velocity will be 7 minus 1/6, that is 41/6. So relative velocity is 41/6 and the distance between them is 49v/10f. So after he collects this ball, after how much time he is going to collect this ball, I am finding it. So that is relative speed into t. T I am calling it as 1/f. T I am calling it as 1/f. So relative speed into t equals to distance. From there I will be getting f is 205/147f. So the other way of saying it is A will be receiving it at a frequency, this thing. Now similarly B is moving this way. Again I will be going with relative speed into time. Time is 1/f equals to distance. So frequency at which B will be collecting the balls is this. So they are asking what is the ratio, right? So option D and option C are correct. So they are asking something about standing wave in the next case. So before that I'll be going with just a like rough reference of where you will be learning it. So for a progressive wave you will be finding what is the kinetic energy, and see from here I can find dk/dx also. If I divide with dx, I will be getting dk/dx. dk/dx will be half mu into this thing, whatever it is. So basically dk/dx will turn out to be half into mu into what is this? This is Vp. Vp is dou y/dou t. So dk/dx will be half mu into dou y/dou t whole square. Similarly potential energy will be force into half into, or du/dx will be force into half into dou y/dou x whole square. So basically I am talking about, if you want to use, you can directly use this. dk/dx is half into mu into dou y/dou t whole square. dou u/dou x equals to half f into dou y/dou x whole square. Now they are talking about standing wave. So there is a standing wave. It will be of this nature. So I need to find what is dou y/dou t and dou y/dou x. So I will be differentiating it and I will be finding it. And I will be substituting it in dou k/dou x. See this dou k/dou x, I wrote it as dk/dx, that's up to you. So when I substitute these values, dou k/dou x is half into mu into dou y by dou t whole square. So you just substitute it, you will be ending up with this result. Now similarly, dou u by dou x will be f into half into dou y by dou x whole square. F is mu into v square. So when you substitute dou y by dou x from here, you will be getting this result. So now dou k by dou x result will turn out to be this thing, dou u by dou x result will turn out to be this thing. So they are talking about node and antinode. So when will it be node? So when kx is 0 or sin kx is 0. So let me talk about one node, one particular node where kx is 0. When it will be antinode, when that particular kx is pi by 2. There will be many, but I am taking kx equals to 0 and kx equals to pi by 2. So when kx equals to 0, this term will be 0, this term will become 1. So I will be getting this is 0, this is going to be 2 mu a square omega square 1 into cos square omega t, cos square omega t. I am substituting it this way. Now when kx is pi by 2, I will be getting 2 mu a square omega square, this is 1, and sin square omega t I am putting it this way. This is going to be 0. Now at the midpoint of them, pi by 4, when kx is pi by 4, you will be getting 1 by root 2. 1 by root 2 whole square, this 2 and this 2 will go, this 2 and this 2 will go. So you will be getting mu a square omega square, sin square omega t, and here cos square omega t. Now they were asking sum of total energy per unit length. So total energy per unit length for antinode guy is this much, for node guy is this much, for antinode guy is this much. So they are asking this summation, this plus this will always be constant. So that plus that, you are getting sin square omega t. See, this is varying with time. This is also varying with time, but their summation is not going to vary with time, it is constant. Now similarly they are asking what is the summation of this thing. Kinetic energy per unit length will vary with time, potential energy per unit length will vary with time, but their summation is going to remain constant. So option A and B both are correct. Now if a string has standing wave and traveling wave, so traveling wave and standing wave, then dou y by dou t, dou y by dou x, kinetic energy per unit length this thing, potential energy per unit length this thing, you will be getting something like this. Now kinetic energy of points of minimum amplitude is not zero at some instant of time. See, now in this particular case you can check, there won't be points which will be always 0. So there for some particular value of x, it may be 0 at that moment, but in the next moment it is not going to be 0. So at some time there will be some energy. These two are the same, so the same explanation goes. Screw gauge of pitch 0.5 mm, circular scale with 50 divisions. So initially it was like this, initially there is an error. So basically they said pitch is 0.5 mm and 50 circular scale divisions. So 50 circular scale division is equals to 0.5 mm, 1 circular scale division equals to 0.01 mm. So there is an error of 5 circular scale divisions. If I want to make this 0 touch here, I have to rotate it by 5 circular scale divisions. So that error is 0.05 mm. So basically if I put the 0 back, I must have rotated by 5 circular scale divisions. So basically if I put an object of this much length, it will be showing me 0. But I know the actual length is 0.05. It is showing me 0, so I should add 0.05. That error is called as negative error, and we will add the value in the end to get the right answer. So now it looks like this. Earlier it was looking like this. When I put an object, it looks like this. So there was one full rotation. And there was extra also. So 0.5 mm is the main scale reading, and if I take it like perfect screw gauge, I will be feeling like earlier 0 was touching, now it is 25. So there is one full scale rotation which is 0.5 mm and 25 circular scale divisions. 25 circular scale divisions, 1 circular scale division is 0.01 mm. So the result I will be feeling it is 0.75 mm. If it is a perfect screw gauge, I will be feeling the measurement is 0.75 mm, but I know it is not a perfect screw gauge, there was an error. So when I want to make 0 coincide here, I have already rotated by 0.05. So yeah, anyway we understood. When I keep an object of 0.05 millimeter, it will be showing 0, but I should add. So I should be adding 0.05 mm. The other way of saying it is, if I rotate by one full circular scale, this 45 will be coming back again. So from 45 again, if I want to go to 25, I should rotate it by 30 divisions. Some people will write it like main scale reading plus 30 circular scale divisions, which will be 0.80 mm. Okay, there is a solid sphere which strikes the vertical wall elastically and stuff. Friction is there between sphere and. Okay, so they said friction between sphere and any surface is mu. Oh, so but I solved it only taking friction here, so probably like you try by yourself. I'll be just explaining the idea. This is going with the velocity v naught and it is elastic collision they said, so velocity of approach equals to velocity of separation, so it will be coming back with velocity v naught itself. So the change in momentum is 2m v naught. So basically I didn't consider the friction here, so for me the only impulsive force in that direction is normal, so impulse due to this normal equals to change in momentum I got. Thereafter I have taken friction here, it is rotating this way, so friction will be this way for him. So that friction is going to be impulsive, so impulse due to that friction is mu times of impulse due to that normal. Now that will give me change in momentum along this direction, change in momentum along that direction. Now this is 2m v naught, so when I do that I will be getting velocity along y axis is 2 mu y naught. I didn't consider this friction, probably I will look into it later. So whatever it is, you need to write impulse equals to change in momentum along x axis, impulse equals to change in momentum along y axis. So when I did that I got velocity along y axis is this much, range is going to be velocity along x axis into time of light. Time of light depends only on the vertical velocity 2vy by g. Now I can see according to my calculation, like when this friction was not there, this velocity depends on the mu value. So this velocity is constant. So the more time of light, the more range it is. It's not like our regular projectile. So the more Vy, the more range it is going to be. So this is the range, the more mu value, the more range it is going to be. So the given answer is 0.5, which is not right. I mean, I think they also didn't consider the friction here. Yeah, I'll be looking into it. I missed it. So if this has to be maximum, mu value has to be maximum. In general, mu value maximum is 1. Now what they have done is they have checked when will horizontal velocity and vertical velocity be equal. Now that need not be the case. See, there for a fixed speed, at what angle we should be throwing this, whatever derivation we have done where horizontal speed and vertical speed must be same or the angle is 45 degrees, that doesn't suit the conditions here because this is independently v naught and this depends on the mu value. So, but in the derivation what we will be doing, we will be taking a fixed speed and not what angle we should be throwing, right? Now the next question, there is pure rolling thing. They are asking find the acceleration of the center of the cylinder related to the wedge. So this kind of thing we have already done. Wedge will be moving in this direction. This thing will be in random motion, but I can visualize this motion like this center's motion like motion of the wedge and motion with respect to wedge. Now again, there is no net horizontal force, so center of mass won't be moving. So m1 into delta x1 plus m2 into delta x2 must be 0, or total m into x in this direction equals to m into x in this direction. So center of mass won't move. So I don't know how you will be learning the equation. So you do it in your own ways. Center of mass position is not changing. So based on that, what is the relation between these displacements? So 10 plus 20 into x, 30x equals to 20x cos 30. 20x cos 30. So the relation between this thing and this thing will turn out to be this. When I differentiate it, if this velocity is capital V, this velocity is capital V, if this velocity is small v. So then when I differentiate it, I will be getting this. What is this capital V? Velocity of the wedge. Small v is velocity of the sphere or cylinder. Cylinder with respect to wedge. Cylinder with respect to wedge. So when I sit on the wedge, cylinder will be going this way and it will be pure rolling also in such a way that this velocity small v equals to r omega. Small v equals to r omega. That will be the pure rolling condition. When I sit on the wedge, small v equals to r omega. Now if this goes down by distance x, drop in potential energy will be mgx sin theta. That will go as kinetic energy of this guy plus kinetic energy of this guy. Kinetic energy of this guy will be translational kinetic energy and rotational kinetic energy. Translational kinetic energy half m into total velocity square. Rotational kinetic energy will be half I omega square. Now how to find omega? Sit on this wedge and see. This velocity is x, so it must be rotating in such a way that this point must be having 0 velocity. So x minus r omega equals to 0, or is v minus r omega equals to 0. So omega will be v by r. Drop in gravitational potential energy equals to increment of this kinetic energy plus increment of this kinetic energy. This guy will have translational kinetic energy and rotational kinetic energy. Then I want to make it into single variable form. So I am converting everything into small v and small x. I am converting this into small v, small v. So those are the two equations. I think similar question was there also. Momentum conservation there and energy conservation. The similar thing. Center of mass is not moving and energy conservation. So when I do that, I'll be getting this relation. Now when I differentiate it, differentiation of x is small v, differentiation of this is 2v into dv by dt. What is that? That is the acceleration with respect to wedge. That's what they asked. The acceleration with respect to wedge is g by 2. So they were saying they have to punch regular hexagons. So basically you can visualize like, yeah, it's like a, if you want to punch paper, punching machine. So what you will be doing? So yeah, let me say like if you are punching the paper, there is, yeah, if I zoom the paper, it will be of some thickness like this. This is the paper. If I want to punch a hole, like look at the circular part what I will be punching. So basically that circular part is filled here. When I am punching it, what will happen? It will be sliding between these regions. So when I am applying a force F, so if the surroundings are applying a force F, then it won't be going out. If I apply more than that providing force, shearing force, if I can apply more than that shearing force, the paper can be punched. Now the paper is getting punched in the form of hexagon part. So length of this thing is, let me say the thickness is t, and so what is going to be the length? So if I draw the hexagon thing, with thickness t, then the length of each side is going to be 1000 t. So what is the area of any one side? Area of one side is going to be this much. So there will be six such things. So basically you can visualize like there is a hexagon magnet surrounded by magnets. So if you want to push that magnet, so other magnet will be exerting a force in this direction, so they will be exerting shearing force. So all the six sides will be exerting shearing force. So shearing stress can't be greater than this thing. So if I can apply a force in such a way that shearing stress is greater than this, then it will be punched. So shearing stress. At the critical condition, we will be going with the equality thing. So shearing stress is given. My applied force 6 into 10 power 5 they give. So my applied force by area, if that is equals to 4 into 10 power 8, that is the critical condition. So from there you will be getting the result. Okay, the next question you can read by yourself. Anyway, the answer doesn't depend on the atmospheric pressure. When the answer doesn't depend on the atmospheric pressure, I won't be considering atmospheric pressure for easy calculation. So in the next free body diagram, I'll be drawing the free body diagram of this cylinder and this water included. I'll be drawing the free body diagram of the cylinder and the water included. So I'll be drawing the free body diagram of the cylinder and this water included. So this is my free body diagram. Here pressure will be linearly increasing, so I can go with force on this face of the water is average pressure into area. Now here pressure everywhere is rho g r, so pressure into area will be in the upward direction. Apart from that, this weight of the liquid will be in the downward direction, that is this much. Now these are the forces because of the water, pressure force and weight. Now the net has to be 0, so this has to be balanced by someone, so I should be applying some force from this side. I'm not bothered about the torque thing, I was just showing like this force should be balanced by this force. And yeah, resultant of these two will be like negative in this direction. The other way of saying it is like there is slightly less in this direction, someone has to apply extra force from this side. So someone will be applying this much extra force from this side, that is me. So I should be applying extra force from this side as well as this side. So what is the resultant I should be applying? Resultant of these two. That will give us the answer, right? Thank you.